All right. So I'll be really quick, Year 9s, because I want to actually, everyone, sorry, my last class, Year 9s, rather than spending too much time on this, because I want to give you guys an opportunity to actually ask some questions and talk to some of the F1 students who are currently competing around the room or have competed before and start to put you in contact with some of them. Basically, what I want to cover in this quick lecture is what are the different competition classes of the competition, what makes up an F1 car, how do the different classes affect an F1 car for the team, where do I find more information? How do I design F1 cars? What is the design process? And what is the My First Car MFC? So let's go really quickly into the rules. If you have a look around the classroom, you'll see these. We've got two new folders here, and types of folders, and I will be leaving these in one of the folder holders just on that little table there in the corner. One is the competition regulations. This is technically orange, though it prints like it's red, and this is the technical regulations. Between the two, all the rules and all you need to know about what is part of the competition is in them, okay? In the technical regulations, though, if you look here behind me, rules 1.5 basically talk about the different competition classes. So if I was to look at how I would actually read these, I'd go to the rules are all labeled here. T1.5, competition classes, page 7. Go to page 7. There they are. Okay, and I've just made a copy of those. But basically, there are three different classes. You've got cadets, as you can see on the screen, development, and professional. The year levels there are suggested, but they are also enforced. But you can get, for example, junior and senior cadet classes, the same as you can get junior and senior professional classes. So there's some mix in this, and you do get judged separately, somewhat. But basically, the reason I wanted to identify this was that because commonly what we do is at the school, and in history gone by, year 8 students effectively pushed a little bit more into the cadet classes unless they're going to spend a lot of time in this, because it gives you an opportunity to compete, to make a car, race a car, learn about that design process, learn about that testing process, but not spend hours and hours and hours in here, especially because if you want to do this competitively and get to that high world levels maybe, it gives you an opportunity to do it for a couple of years, and you can only do cadet class once. Once you've done cadets, you can't do it again. So one of the rules about that is you can only do that class before you may do another one. Development then is generally what we get kids who start in year 9 to do, and professional is what we do usually for students who are in year 10. And that's pretty much exactly what happened with this group of students that just went through Horizon Perspective, and we had another group called Fuchsia that went to the state comp, and we talked about that before. The reason this is important is there are different rules for different classes. Okay, and that turns out in what you need to do to hand up for submission and what you can do with the design and manufacture of your cars. Okay, so I'm talking here with the one in front of me with a professional car, and so it has no wings, front or back. It has no tether guides, front or back. And it has no wheel and axle support systems. There's nowhere to put your wheels on there. There's no axles, right? Or holes to put axles into. Because in professional, you can make those out of custom materials compared to development or cadet, where you're not allowed to, some of them, right? So depending on what you want to do with your designs, how complex you want to get, that can affect what choice of classes you want to be in. So we'll have a quick look. Cars, right? This is called the F1 in Schools program. It's all about the F1 car, right? So in terms of when we're talking about these, we've got a number of different parts. You've got the main body, okay, including something called the virtual cargo here. You've got your side pods, which are the two pods either side of your cars. You've got the nose cone, which is basically that front section there. You've got front wings, which are the two wings either side. You've got your wing support structures if there's something holding that onto the nose cone or maybe around it, which if you look at some of the cars around the room, you'll spot. You've got surface finishing and decals, and that's just on all the cars, okay? We obviously don't hand them up or race them when they look like a bit of wood, right? Or when they're like foam. So there's some surface finishing and decals that go into making them look good. We've got a rear wing, which is up the back, obviously, okay? We've got a CO2 canister, which is where hole, which is here, and we've got the chamber, which is actually the hole, but then we've also got just the CO2 canister area, which is the whole space around it. Okay, you've got the tetherline guides, which on here you can't see. James, could you just throw me one of those two cars? Cheers. You've got tetherline guides, maybe not literally, yeah. You've got tetherline guides, which basically, if you don't know, have a cable going through the tether line, which holds this on the track when it races down the 20-meter track to make sure it doesn't launch off and hit someone, right? So that's a safety feature, like in a real F1 car. And that's effectively the majority of the components you would have in most cars, okay? There's sometimes a little bit more or less. Where is that image found? Well, it's T1.6, page 8, found in the technical regulations as I highlighted there, okay? This is just to remind you that you guys should be downloading and having a look at this if you're quite interested in it. The cars, no, I just did that. The rule differences per class, you can see an image there of a development and a cadet class that's similar compared to a professional car. Some differences you might note include the complexity, how different they look, and also the wheels. Notice that the wheels are different. Okay, so in a development and cadet car you have, and this is interpretable and it changes quite quickly depending on the year level, so we're waiting on 2018-2019 competition rules, okay, for you guys, but so far we're just going to run with the 2017-18 season. Development and cadet only allow 2 sides for machining. REA standard wheel systems, which means they're these black plastic wheels that you can't change, and I've got boxes of them. I buy them in a pack of 100. And balsa rear wing with potentially 3D printed front wing, I believe, is how that works. And rear?
No, but you are allowed to have a front wing.
Yeah, 3D printed front wing. So just confirming with my very knowledgeable students there. So that's Tom's car there, and you can see that. And his complex front wing, he was only able to do via 3D printing. That would have been able to be machined from 2 sides. Okay, so if you can imagine, and this is why I brought the blocks out, your cars start life digitally as an idea, but then need to be made physically. And to be made physically, you start with a block of material. So we use a manufacturing process called subtractive manufacturing, which means you subtract material to make what you want, rather than additive, which is 3D printing, which adds material to make what you want, okay? So the subtractive process goes where you've got a block, it gets put in a machine, a CNC, right? And we'll talk about this in a minute. And then it gets machined out with a drill bit, okay? Imagine like mum and dad were putting something on the wall to hang, like a screw or a nail. They use a hammer, but you know, there's that kind of long rod that they might be, well, okay, a drill bit, imagine my pen's the drill bit, would be moved by a computer across that material. Okay, it's programmed to do that in a certain way, in a certain pattern, to then produce your design. Now, if you've got a professional car, you can have any side, any angle. So you could machine that from all 4 sides, 1 side, 2 side, 3 side, 4 side, compared to the development or cadet, where you can only do 1 side, and then you can only do the opposite side to do the rest of the car. Okay? You're allowed any wheel and axle system compared to the REA standard ones. You've got more composite parts and systems allowed as well. For example, the wings, the wheel and axle assemblies, tetherline guides. So there's much more freedom in design with the professional class. But again, like I would suggest that you don't do a professional class unless you've done the development or a cadet before, because there's a lot more complexity to get that to work correctly.
And the standard of competition style as well.
Exactly right. You're going to be versing older year level students. A lot of you are a lot younger in this room. So there's an element of that involved in choosing what kind of team you want to be in. So let's have a quick look at some potential design processes. Now, a design process is kind of like the steps you would take to go from an idea to a finished design, and then from a finished design to a refined design, and then a continually refined design, and we'll look at that in a minute. But I've just put 2 images that I commonly use to explain this up on the board. So you've got an engineering design process here, which is ask, identify, and need, the need and the constraints. So this is where you're trying to identify what you're trying to produce and what constraints limit what you're trying to produce. Research the problem, understand it more, understand the rules and regulations. Imagine and develop possible solutions. Moving on to plan and selected promising solutions. So plan how you're going to produce it. To creating and building a prototype, testing and evaluating the prototype, and then improve and redesign as needed. So you would go back, right, from the improve and redesign to asking, identifying the needed constraints. So, it was good, but it could have been better. Okay, what could have been better? The aerodynamics. All right, so now you've identified a new need or new constraint. The aerodynamics need to be improved. So this is very basic. You get a lot more, like more fancy looking ones, which is a little bit more basic again and can be applied to lots of different programs, not just F1. But effectively, you kind of run through steps to be able to get to your end preferred solution. So what I've done here is I've just written down some examples of what I would suggest you guys basically start doing in your own time, coming in at lunchtimes or recess or after school and doing on your own. Because I think, and as I've discussed before with you, the best process for attacking this competition is to start with all of you guys being able to make a car, as in design a car. All of you understanding how to test that car aerodynamic. Thank you. I think it's got a limit because of the number of gigabytes it takes up. So hopefully we haven't missed too much. If you have, we're just discussing what I would suggest to be done for a design process for you guys to get more familiar with the program. And what we were hoping is you guys would have a go at this before the end of the term or through the holidays as well, if you've got access to computer systems at home. So, once you've done that, the idea would be, okay, you would know whether or not you want to be an engineer for designing or manufacturing, or whether or not you prefer to be involved but being a team manager or a graphic designer or an industry specialist, like I talked about the different roles last week. So you may already have an idea about that. You may already be in a team where you've already talked about that, and that's fine. So you can stay with that. But if you haven't, my suggestion would be that you go basically through this design steps, such as creating the My First Car, using the video tutorials and the drawings, identifying areas for improvement, i.e. areas not legal, because there are illegal components on that My First Car design. It was designed a number of years ago when the rules were different, and also it was designed to test students to actually try and solve it. Research what changes could be made, what knowledge you need to know, create and modify the design, use analysis software to test whether improvements were made, okay? So how would you do this? Well, if you don't already know, we use design programs such as Fusion 360 and CATIA to do these. I would push you towards Fusion 360 to start with, to try this out. And I'll show you where you can get access to these slides and the video recordings from the previous lectures and where I keep putting them up to, which then you can use the hyperlinks, right? So Autodesk Fusion 360 is free. You just need to use your school email to create a student account, and you say, I registered this year, I'll be here for 5 years as a student, please give me access. But you can also always just come in to this room and use these computers, and that's what I would suggest you do if you want to really become part of this competition. And if you're not necessarily here, you can come in at any lunchtime and basically have a go at that and talk to the existing students. So CNC manufacture, like I said, is done on a Denford, okay, which is a computer numerically controlled machine, i.e. a robot. It uses numbers, ones and zeros, to control that tool path to move across the material, cutting it out as it goes carefully to produce your design or your prototype. I wanted to show you quickly a couple of videos of the changes that might occur. So this is prototype 1, right, for Aurora, and you can see that this is where they started with when they designed their model. Okay, and then as they developed this along, you'll notice that changes were slower and subtle, but also some were rather large and obvious. So the front nose cone has changed. The side pods have definitely quite distinctly changed. It's gotten a lot wider. Go to number 3 now, and you can see a lot more changes again. Some parts have simplified, some parts have got more complicated. All right, so this kind of process is what engineers will be going through to modify what they want their car to be like, okay? Whether that's because of the rules need them to change, whether it's not very aerodynamic and they need to modify it again, whether or not they think they've got a better design that is more strong. Now, what we aim for in our design process is another whole video, another whole lecture, so on and so forth, that we'll go through at another time. Is that still recording, guys? Cool. And we will look at that at another point. This is just like the basic introduction into starting that process for you guys to have a go at actually designing. And then you've got, of course, your final car design, which is obviously the end of that refinement process. Okay? But from the basics, it starts with teams need to start making cars. And if you're interested in this at all, this is where I suggest you have a go in your own time as well. So just so you know what the actual manufacture process looks like, have a look at the machine there, actually cutting out through the wood, moving around automatically, doing all the different sides, slowly machining away the material in that subtractive process to produce the final car. And that was the majority of what I wanted to cover today. So this presentation, I have created, knocked something off, a small website which I linked into Daymap. So if you've gone to school communications before, or if you're hungry teacher read this today, week 10 year F1 program here, there's a link to what's called the BSS F1 program page, and I suggest you have a look at this and save it. Basically, all it is a really quick Google site which details what the program is at Brighton, an overview of what that program looks like as a competition across the world, and then under program information, you've got the introductory video from last week, and you've got the introductory presentations that I've done so far. And so this one that I've done today, I'll edit tonight and upload as well, and I'll also put the slides on so you can go back and have a look. So if you've got friends that didn't make it or are interested, just give them a nudge towards this link and save it so that you can use it, because it may not always be on Daymap for you to find. Does anyone have any questions? So we've got a bit more time now, and this is where I suggest that potentially, if you are interested in car design and all the rest of that, you maybe have a go at logging into a computer and creating an Autodesk account. If you would like to talk to me more generally about the competition, or Mr. Barrett, who's at the back there, please do. Thank you for listening. Huh? That's fine, you can use that.
Yeah.